The Monty Hall problem. This is a famous math puzzle in the area of probabilities. There are tons of videos about it, but this is my way to solve it, which I personally like because I find it straightforward. Here's the problem statement. There are 3 closed doors, and your friend tells you that he put a car behind one of them and a goat behind each of the other 2 doors. He tells you to pick one of the doors, and if the door chosen has the car, you can keep it. You may love goats, but you really need a car, so you want to get it. So you make your choice and point the door you want to open. However, before the chosen door is opened, your friend, who knows exactly which door has the car and which doors have the goats, tells you that he will open a different door from the one you chose that has a goat behind it. Suppose, for example, that it's the leftmost door. Note that the door he opened with a goat behind is not the one you chose. And this is always possible because you originally pointed to a door, but there are 2 doors with goats, so there must be at least one door different from yours with a goat behind it. Now you have seen a door different from the one you chose with a goat in it. Your door is still closed, so you don't know if it has the other goat or the car. And now your friend asks you if you want to reconsider your choice. At this point, there is only one other door for you to pick. So he is basically asking if you want to stick to your original choice or if you want to switch to the other closed door. What should you do, if possible, to increase your chances to pick the door with the car behind? In other words, between the 2 strategies, sticking to your original choice or switching to the alternative is one better than the other. You can pause here and think about it. So now I'll continue with the solution. There are essentially 2 things to note. First, by staying with your original choice, you have 1 in 3 chances of finding the car. That's the chance you had for guessing correctly 1 out of 3 options. None of what happened after you made your choice is affecting your odds. Your friend showing you another door with a goat does not change your odds. So the probability of winning the car if you stay with your original choice is 1/3. The second thing to note is that once your friend showed you a door with a goat different from the door you chose, then the car is either behind the door you chose or behind the other closed door you could still switch to. So, if with the strategy stay, you find the car, then with strategy switch, you miss the car. And conversely, if with the strategy stay, you miss the car, then with strategy switch, you find the car. So the events finding the car with the stay strategy and finding the car with switch strategy are complementary. They are mutually exclusive, and at least one of them must happen. This implies that the probability of finding the car with the switching strategy is equal to 1 minus the probability of finding the car with the staying strategy. But we know the probability of winning the car by staying is 1/3. So the chances of finding the car with the switch strategy is twice as much as finding the car with the stay strategy. So the strategy of switching doubles the chances to win the car.